My name is Sandeep Pingle. I wanted to tell you something about the Etabs workshop that we generally conduct. So this is the syllabus that we generally cover during the workshop. This is the advanced workshop. We generally conduct two types of workshop. One is the Etabs corporate workshop and another one is the Etabs advanced workshop actually. So this is the syllabus for the advanced workshop. The day one is generally consists of introduction, modeling process and the techniques. These are the topics actually, the 11 topics that we generally cover during the first day of advanced workshop. These are the topics in which the complete software introduction, capabilities, strength and weaknesses, the geometry creating process, 2D, 3D, IFC, then Revit structures, how we can input the file, export the file, etc. So those things would be conducted during the first day. The third topic would be covered is these are the simple commands actually, how we can generate the model. In Etabs actually there are 2-3 different types of different techniques are there in which you can generate the model very quickly. Then the complex modeling, foundation system modeling and the building modeling together actually, if we do, then what all the advantages, disadvantages that you will get, that we will see. Multiple tower modeling also we'll see with the separation joint, different types of loadings, dead load, live load, earthquake load, temperature load, different types of earthquake load also, like static, dynamic. In the dynamic we have the response spectrum, time history, etc. Some non-linear factors also we'll consider, which is p delta, creep and shrinkage, etc. So this is also will be considered during the first day, that what is creep, what is shrinkage, how you can incorporate those effects into the modeling processes and when it is required. The seventh topic that we will be discussing is the area springs, point springs, releases, supports, diaphragms and other definition parameters. Other definition parameters are like, when we are going to use the thin shell element, brick element, which is the thick shell element actually. Then we have the membrane elements, etc. So those type of elements we will be checking into this. Eighth type is optimized Etabs model with the Maivan technology. If we are using the Maivan shuttering or the centering material instead of a brick wall or a block wall, if RCC Maivan wall is there, then what all the effects actually which we have to take into consideration as a structural engineer. Then how to check the mathematical model in Etabs. Then there are pre-analysis checks for before you do the analysis, what all the checks that you need to consider, whether the model is done properly or not. This is for that. And the 11th and the last topic that on the very first day we will be checking is the static earthquake and the dynamic earthquake, generation of the scale factor, etc. So these are generally the introduction and the modeling process and the techniques actually which we will be discussing during the first day. The second day is more of the analysis actually. What all the different analysis techniques, processes are there, when to use what type of analysis. There are a bunch of series of different types of analysis are there in Etabs, like for example linear, non-linear, sequential analysis, static analysis, dynamic analysis. Okay, so use of such type of analysis techniques and the methodology and the parameters. So let's say for example p delta analysis if you want to do. First of all, why to do the p delta analysis? Secondly, if the use of the p delta is mandate, then how to do that? What all the different types of parameters that we need to check, and after checking those parameters, how to get the results and how does it hampering the results and to the design, how it we will be contributing those factors into the design. So all these techniques and the parameters that we will be studying actually during the analysis process. Outriggers, I mean, this is for the high-rise buildings. If you want to use the outriggers in the building, what all the advantages are there? Nobody want to add the outriggers to get the disadvantages, but by adding the outriggers there are some loopholes or the potholes, I would say, that you are adding the stiffness irregularity in the building. So adjacent floor need to be designed for certain different techniques. By considering the different techniques, how to take care of those floors while performing the analysis and modeling processes, etc. So that we will be checking. The third topic is the geometric and material non-linearity. Okay, so geometric and material non-linearity of the building, having the transfer gutter. I mean, generally, the buildings, the columns and the shear walls are not going straight down to the foundation, right from the top floor. Sometimes you have to have the transfer gutters because of the driveways, because of the car parks, during the parking or the podium areas or the basement areas. And in the typical floor, the habitable floor plate will not match with the floor plates which are there at the foundation and the podium floors. So in such case, actually the transfer gutters becomes mandatory for facilitating the architectural features. So in order to add such kind of features, what all the things that you need to consider? So those effects will be taking into consideration. The fourth thing is differentiation between the earthquake engineering and the wind engineering. Now this is the concepts. These are the concepts actually will be taking during the workshop. Designing, detailing and their methodologies accepted worldwide. So what's the key difference between the earthquake and the wind? Both are the horizontal forces. The base shear difference is the analogy, the ground motion. When we have to have a ductility, the wind engineering, what all the parameters that we need to consider, like for example vibrations. Earthquake, what all the parameters that we need to consider. So those things we will be taking into consideration while performing the analysis. International norms for the high-rise building analysis. Now there are various different codes are there, in which let's say UBC 97 is there. If you come to the Indian code, actually IS 1893 code is there. For AC code is there for the wind engineering. So certain international codes, American codes, Australian codes, Indian codes, Euro codes. Okay, so what all the different norms that you will be considering whenever you are modeling any high-rise buildings, that we will see into this. The sixth topic is the wind tunnel analysis and its use in the high-rise building. So wind tunnel analysis, we need to have the Etabs, certain mass moment of inertia and certain physical properties we need to give and take to the wind tunnel consultant. So how to do that actually, how to standardize that wind model which the wind engineering consultant is going to do it in their laboratory, and how to standardize that as a prototype model for the entire building, for the main building. So that we'll be checking as the sixth point. Then the high-rise committee norm. There are some high-rise committees are there worldwide. So what all generally the techniques that individual committee checks whenever it comes to the proof checking. Eighth point is why non-linear analysis. See, generally worldwide the linear analysis only considers as a primary module for any low-rise or high-rise buildings, but non-linear analysis is also very important. Let's say for example P delta, let's say buckling analysis or the creep analysis. In certain areas such type of analysis becomes very vital important. So when to do what type of analysis, why to do it, how to do it, what all the parameters we need to consider, how to consider, when we add those parameters, how the software will perform. After the software is performing, how to check those parameters after performing the analysis, and then how we get into the design. So those aspects will be studying into this. The next is the modal analysis. I mean, generally the modal analysis and its use in the dynamic and the time history analysis. So, which is FNA, and various different types of analysis are there when it comes with the time history functions. The next, which is even far more advanced part actually, which is the performance based analysis. So first of all, it's very very important to understand what is modal analysis. It is, I would say that it is the encyclopedia of the building, that how, or the open source code of the building, which is the modal analysis that you'll be getting it after you perform it. So modal mass participation ratios, then how the number of modes are, individual modes are behaving, or the first mode, second mode, third mode, or different modal combinations, how the building is behaving different at different modes. So those type of things we'll be studying into this. Work versus, or the energy versus work diagrams and its application. This is also very important area, that which part of the building is governing most at which particular load case, and how to use this actually in the real project. Okay, so this is also extremely important, specifically if you want to change the first mode from the torsion to the translation, for example. So such kind of themes would help you to understand that which part of the building would contribute more for that particular model analysis, or even in the dead load live load analysis it's important. 11th part is the modeling of the composite structures. Not only composite, we'll be checking the RCC structure, we'll be checking the steel structure as well as the composite structures, and that is steel plus RCC. So how to model the composite structures, steel structures in Etabs, that we'll be studying. The last part is also extremely important, which is the lateral stability checks. Now, lateral stability checks is generally carried out after the post analysis, and sometimes you need to do the iterative process if the stability is not within the limits of the serviceability and strength constraint. Then you need to unlock the model, start modeling right from the scratch and redo it. So there are so many things that we need to consider: the drift limits, the deflections, the stress limits, crack widths, and the serviceability checks. As well as when it goes to the design, the strength design criteria. Generally the third day is majorly for the design constraint. Now, or the design aspect. Design is like, how to design the columns, beams, slabs, shear walls, transfer slab, brace elements, etc. So third day would be majorly for the design. Then the structural design optimization. I mean, anybody can design the building, but optimization is very important. Economical parameters are also extremely important. Then the third point is foundation system and the soil structure interaction. The third and fourth point are basically based on the foundation system of a building, on which the entire load is going to get transferred to the soil. So how the structure behaves based on the different strata, how the whether the shear criteria will govern, where the bending criteria will govern, or where both the criteria would govern simultaneously at different locations. What all the spoil springs that are they going to act constantly over the entire raft, or there are some different parameters based on the loading considerations. Let's say the central core, if the loads are more, then the peripheral columns, the central core will have little less stiffness, because this stiffness contributes with the load divided by the settlement. Okay, so many things that we generally discuss during these two chapters, which is the foundation system and the soil structure interaction. The fifth topic is also allied with the third and fourth, which is the pile raft foundation and optimization technique. Sometimes only the raft is not enough, sometimes only the piles are not enough, sometimes we have to go for the pile plus raft combinations. So soil spring also will be there, as well as the point springs also will be there, the mathematical model. So in that case, how to optimize the raft. Okay, so those things will be covering during the third day. Fifth topic. The sixth topic is checking the foundation system, basically for the deflection and the crack width, as well as the reinforcement checking. The deflection, maybe it is for the short term or maybe for long term by considering the creep parameters. Okay, and the crack width as well as the reinforcement checking. So those things will be covering. The seventh topic is the differential settlement of the foundation and its control. Okay, so majorly these 3 days, as a feast of so many topics that we generally cover, I would like to give you a small introductory uh, model. We'll generate a small model quickly. How quickly the model can be generated, I'll show you. So let's say this is the first screen actually. Yeah, you can go to the file, new model. Okay, SI system, and these are the general database that you can add into the system. You can go to the particular database also, let's say European, Indian, Russian, American, okay, Chinese, so Euro codes. So various systems are there. We'll just skip this topic, but this depends upon the different zones actually. So let's say you are there in the Eurozone, you are there in the Italian, or you are there into the New Zealand codes or the British codes. Okay, so based on different areas you can define these topics or these settings. Now once you do that, I'll just go to the blank option. We'll study that how we can import the model through the 3D. Okay, I'll just paste the path over here to import the DXF file. So we are importing the DXF file, 43 story building. How we can quickly generate the mathematical model that we will be checking into this. Now we can see that the mathematical model is getting generated. So let's say 42 story. Okay, so let's say assignment 1. So you can see how quickly the model has got generated. Now this is very important, that Etabs is very user friendly, very robust software when it comes to the modeling analysis as well as design. Now if you want to see the model in the 3D rendered view form, so this is that model. Within just a few seconds actually, you can generate the model through the 3D DXF command. So sometimes the complicated models can be easily generated through the 3D DXF. Now how to do that 3D DXF also will give you the separate training for that. Okay, a skilled draftsman you must allocate to whom you trust actually, because his mistake will become your mistake. Okay, so majorly the CAD related parameters governs at those areas. This is generally for this technique is useful for very high rise building and the complicated building kind of projects. Now let us say you want to allocate the slabs. Okay, so I'll just select the slabs and allocate, instead of the deck slab, I'll allocate the slab one. So you can go to the any floor, you will see the slab is there. If you see undo here, there is a deck slab. Okay, so it's a decking, so we just change it to the slab one, which is 200 thick, actually thin shell element. Okay, so after that we will be giving the loadings. So let us say that I'll select this slab and I'll add the loads. Okay, so dead load will add, which is the superimposed dead load, let's say 2 kilonewton per meter square. I will select the previous live load. Since it's residential, we'll also add the 2 kilonewton per meter square. Generally in the lift area we'll add some more load, let's say 1 kilonewton per meter square extra load, we'll add it at the lift. So like that the loading can be given. Yeah, one more thing I wanted to tell you is, like, you can select the beams for giving the brick load or a block load. It's a wall loading. So let us say you are having 10 kilonewton per meter. That's a load, actually that's for the wall. Okay, so that's how the loading can be given. Once the loading is given, actually the mathematical model is ready for running the analysis. Okay, so it will just run the analysis. Okay, so here in this case, actually you can generate the earthquake cases. From here you can generate the wind load cases. So many things you can do into this. Currently we are having only the dead load layout. Okay, so that's how the quick mathematical model generation can be done in Etabs, and a robust mathematical modeling and the subsequent analysis and the design can be done. Thank you very much for observing this video. Bye bye.